So now let me show you one example of round robin algorithm. So this thing will become very much clear to you. Okay, that is my promise. So your Gantt chart is starting at time t equal to 0. So before you schedule any process at any time, let's say at time t equal to 0, you are trying to schedule a particular process. So before you do that, you go ahead and update the queue and see which are the processes that have arrived in the system by this time. Okay, so now we are standing at time t equal to 0. So before you schedule any process, go and update the queue, okay, and check what are the processes that have arrived in the queue. So time t equal to 0, only process P1 has arrived. So process P1 is there. So your queue is updated. Now come into the Gantt chart and schedule the first process that is standing in the queue, that is P1. Go ahead and schedule P1. So even though, so the moment you are scheduling process P1, this process P1 is removed from the queue. Alright. So for how much time this P1 will be running? For time quantum value, that is 2 unit. Okay. So 0 to 2 this P1 will be running, and this 5 will be becoming 3. So why 3? Because 5 minus 2 is equal to 3. So now at time t equal to 2, before scheduling your next process, please go and update the queue. So by the time t equal to 2, what are the processes that have arrived? So process P2 and process P3, write it down, process P2 and process P3. Now the catch is your process P1 over? Answer is no, because process P1 requires 3 more unit of burst time. So after updating the queue, push this P1 into the queue also. Okay. So now your queue is updated. At time t equal to 2, refer the process which is standing in front of the queue, that is process P2. Go and schedule process P2. Okay. And now pop this P2 and remove this P2 from the front of the queue. And for how much time P2 will be running? That too for 2 unit of time. 2 plus 2 up to 4 this P2 will be running. Now the burst time of P2 becomes 4 minus 2, that is 2 unit of time. So now again we are at time t equal to 4. What I have told you, before you schedule any process here, please go ahead and update the queue. So at time t equal to 4, is there any new process? Yes, there is. Which one is that? Process P4. Push that process P4 in the queue. So now if I ask you a question, so are you done with updating the queue? Answer will be no, because you have not considered the P2. So now this P2 ran for 2 units. Okay, this P2 is asking for 2 more unit of burst times. So this P2 is not over yet. That is why put this P2 again in the queue. Okay, now see which process is standing in front of the queue, that is P3. Schedule this process P3, remove this from the queue. So for how much time? That is for 2 more unit, that is 6. This 2 will be becoming 0. Before you schedule any process at time t equal to 6, go ahead and update the queue. So do you think any new process have arrived? Answer is no, because the last process arrived at time t equal to 4. So do you have to again push process P3? No. Why so? Because process 3 is already over. So now your queue is up to date. Alright. So now let's schedule that process who is standing in front of the queue. Which one is that? That is P1. Okay. So P1 is asking for 3 more unit of time, but we will be allowing 2 more unit. So this 3 will be becoming how much? 1. So this P1 will be running till 6 plus 2, that is 8 unit. So now before you schedule the next process, go and update the queue. So do you have any new process? That is no. So are you done with process P1? Answer is also no, because P1 is expecting 1 more unit. So even though you popped out P1 from the queue, because process P1 is expecting 1 more unit of time, you will have to push process P1 again here. Now go ahead and schedule the process which is standing in front of the queue, that is P4. Schedule process P4 here. If you are allocating 2 unit of time to process P4, the last 1 unit of time will be wasted, because your CPU will not be doing anything. So let's not do that. What we will be doing, this P4 will be allocated for only 1 unit of time, that is 8 plus 1 is equal to 9. After 9, this 1 will be becoming 0. Okay, then go ahead and schedule the new process. You don't have to wait till the entire time quantum value. Okay, so when you schedule P4 was taken from this queue. Okay, now P4 is over, so you don't have to push P4 again. Okay, at time t equal to 9, see what is the process at the in front of the queue, that is process P2. That is process P2. Okay, how much time process P2 is expecting? That is 2 unit. We will be allowing at most 2 unit. So 9 plus 2, that becomes 11. Okay, so what will happen? P2 is over. P2 is over now. Okay, so as a result, P2 will not be pushed back again. And also, when you schedule this process P2, you already took this process P2 from the queue. So now you are at time t equal to 11. So at time t equal to 11, there is no new process, and you were executing this process P2. And the good side is process P2 is also over. So you don't have to push process P2 again. Now see which process is standing in front of the queue. That is process P1. Take this process P1 and run this process. For how much time? 2 unit of continuous window. Okay. but process P1 is expecting only 1 unit of time. So why to waste your time in giving 2 unit? Why to waste time? Let's give only 1 unit of time and go to the next process. So now P1 will be running for 1 more unit of time, that is 11 plus 1 is 12. So the moment you scheduled process P1, just before that you had to pop this process P1 from the queue also. So now after 12 unit of time, you will be seeing this queue is empty. Okay. So that means you are done with the round robin algorithm. So now let's fill the entire table. So that is completion time, okay, then turnaround time, then maybe wait time, and then response time. Okay. So I have told you already that while filling the completion time, always come from the right side. So at the very first there is P1. So when this P1 was completed? At 12. When P2 was completed? At 11. Okay, let me change the color. When P1 was completed at 12, when P2 was completed at time t equal to 11, when P4 was completed at time t equal to 9, then again keep on going, when this P3 was completed at time t equal to 6. So what is the turnaround time? Turnaround time is completion time minus arrival time. So how much? 12 minus 0 is 12, 11 minus 1 is 10, 6 minus 2 is 4, 9 minus 4 is 5. So now let's see wait time. So what is the wait time? So we know turnaround time equal to wait time plus burst time. So what will be the wait time? Wait time will be turnaround time minus burst time. Okay. So 12 minus original burst time, that was 5. So 12 minus 5 is 7. Then 10 minus 4, how much it is? 6. Then 4 minus 2, how much it is? 2. Then 5 minus 1, how much it is? 4. Okay. So now comes the response time. So while calculating the response time, always move from left to right. So what is response time? Response time is the time duration between a arrival of a process and the time in which the process is scheduled for the first time. When this process P1 was scheduled at time t equal to 0, okay, let me change the color. When the process P1 was scheduled at time t equal to 0, when process P1 arrived at time t equal to 0, what is the difference between 0 and 0? That is 0. So again, when the process P2 was scheduled for the first time, that is time t equal to 2. And when this process P2 has arrived at time t equal to 1, so what is the difference between 2 and 1? That is 1. So again keep on going like this. When the process P3 was scheduled for the first time at time t equal to 4, and when it arrived at time t equal to 2, so what is the difference between 4 and 2? That is 2. And again keep on like going like this. Process P1 we have already calculated. Process P4, okay, we are yet to calculate process P4. When process P4 was scheduled for the first time, that is time t equal to 8, when it has arrived at time t equal to 4, the difference between 8 minus 4 is 4. So one new concept, let's say someone is asking you what is the number of context switches in this Gantt chart. Okay, how to answer that? Just look at the number of cells in the Gantt chart. Okay, so these are the cells. Okay, so how many cells are there? 1, 2, 3, 4, 5, 6, 7. So there are total, in total there are 7 number of cells. So in total there are 7 number of context switches. All right.